All right, guys, welcome to the second day of Unit 3. Yesterday we were talking about ions and being able to predict charges of ions. And so today we're going to start really digging deep into what ionic bonding is. All right, we have a decent amount of objectives today, but I promise you it's not too bad. So you're going to be able to depict ionic bonding using electron dot structures, so those Lewis dot structures we've been doing. You are going to be able to explain what happens to electrons when we have an ionic bond. And we're going to be able to name simple ionic compounds given the chemical formula and determine the formula based on the name. All right. So we have learned, right, as of yesterday, that atoms want to have the same number of electrons as noble gases, right? They want to become stable. They want to have that full octet. Okay, because as I said, right, it's the most stable configuration. And so for some atoms, they want to gain or lose electrons to achieve this full octet. Okay, right, an example we looked at yesterday, right, was we saw sodium, right, wanted to get rid of that one electron. Okay, and when it got rid of that one electron, it formed an Na plus 1, right? And so anytime we have an ion and it's in Lewis dot structure, okay? Anytime I have an ion, I'm going to put it in brackets, okay? Right? We saw the same thing with Cl, right? It had 7 valence electrons. To get to 8, it wanted to gain 1, right? And so when I gained that 1 electron, I became a -1 charge. And again, I put it in brackets, right? So if I look at Na, right, I'm losing that electron. Where does it go? Right? And when I'm gaining this electron here, where did it come from? All right. The best way to answer that, hold on, sorry about that, guys. I always forget to put my computer on Do Not Disturb, right? When I look at ionic bonds, right, 1 electron is being transferred between the atoms, right? This 1 electron of sodium is leaving, right? We're losing it, and it's completely giving it over to chlorine, right? So that 1 electron is being completely transferred between the atoms, right? Causing these positive and negative charges. And like we said, right, positive and negative attract each other, and we form a bond of NaCl, okay? Right? So Na plus and Cl minus, opposites attract, and that NaCl bond is formed, okay? And as we said yesterday, ionic bonds are going to require the complete transfer of electrons, right? We're composed of metal cations, non-metal anions, right? So a metal and a non-metal coming together, a positive and a negative coming together, okay? And although these are composed of ions, overall my compound as a whole is neutral, right? Meaning, right, I have an Na plus, Cl minus, so I have 2 charges, but when they come together, my overall charge of my compound is 0. Because my total positive charge, right, my positive 1, right, is going to be equal to my -1, right? So 1 equals 1. So let's look at this example here, right? If I have magnesium and chlorine, right? Magnesium wants to lose 2 electrons, right? It's easier to lose 2 than to gain 6. And chlorine wants to gain 1. So based on ionic bonding, okay, magnesium is going to completely give away 1 of its electrons to chlorine to fill its octet, okay? So now I'm left with this, right? I have a full octet of chlorine, and I have a magnesium with 1 more electron to give away, okay? How it's going to do that is if I looked and saw that I had another chlorine, okay, I could then give that extra electron over to a second chlorine. So now magnesium has its full octet, and chlorine, I have 2 atoms of, or 2 ions of chlorine, and they now each have a full octet. So now all 3 atoms are stable, okay? How I would write this, okay, is that when magnesium gave up 2, it's going to have a 2+ charge. Each of my chlorines gained an electron, and so I'm going to have a -1 charge. Okay. This one magnesium is attracted then to these 2 chlorines, right? Because my overall charges need to equal out to each other, right? So if I have a 2+, overall I need to have a 2-, right? And I get my 2- from my 1- here and my 1- here. And so it's going to create a MgCl2 because I have 1 atom of magnesium and I have 2 atoms, or 2 ions, I should say, of chlorine. Okay, my subscript will tell me how many ions or atoms are present. If I don't have a subscript, that means I only have 1, right? So MgCl2, Mg doesn't have a subscript, so I have 1 of Mg, and I have 2 Cls. All right. What I want you to do right now is you can pause the video because I want you to draw this example of lithium and oxygen in your notes. Okay. So, same thing that we saw with Mg and Cl, right? Lithium has 1 valence electron, okay? Oxygen has 6. So oxygen wants to gain 2. It can gain 1 from 1 lithium here, and it can gain the other from another lithium, okay? When lithium loses an electron, it becomes a positive. When oxygen gains its 2 electrons to fill its octet, it becomes a 2-. Okay, and so I need a 2-, I need a total of 2 positives to equal each other out to get an overall neutral. So I'm going to have an Li2, because I have 2 Li's, O. Okay, and so when we can take our Lewis dot structures and create a formula from it, okay, this is what it's going to look like. Okay, I have my elements in my compound here are in blue, right? They're just my chemical symbols. Find those on my periodic table. Then I have my subscript, okay? My subscript tells me my number of atoms in my compound, right? So in this case, I had 2 lithiums and I had 1 oxygen. So I have Li2O, all right? So that is the basis of ionic compounds. I'm going to stop the video here and I'm going to put a part 2 up for the next part of how we name and create formulas, all right?